3D demo file here. And so I recommend that you do actually draw some of this up first before you do your 3D. Because you'll notice as I'm drawing, I'll be starting to refer to some of these dimensions. And even though they will flatten out in 3D, it'll still be possible for me to zoom in and have a look at what the dimensions are so I can do a quick check before I draw them up. So, looking at this drawing here, the first thing that I've done is I've traced around the abutment in plan view, and also the thin bit that sticks up as well. So this is one big P line. It has to be a P line to work in 3D. This is also a P line, and the same on the other side as well. One P line right round. And I've drawn a line from that point there to the point on the other side, just to check. When I click on it and go list, it should say 1300, 13 meters, sorry, 13,000. I've also taken the trouble to add the columns up here as a P line. Column over here is a P line, and the column over here is a P line. Now, it's kind of a bit messy if we do it on top of this drawing, so I've copied all the yellow stuff up the top, ready to go. And these reference points here are points where the beam and the column intersect. In this case, the column here goes right within 15 mils of the end, and the beam over here comes in, it's offsetting from the end, because eventually we're going to end up needing that location. So, looks pretty simple at the moment. Alright, I'm going to right click here and undock this. I'm going to set up my normal OP in AutoCAD. This is something that I would advise you do at this stage. If you haven't been using this way of doing AutoCAD, it's better to do it on AutoCAD Classic. The commands will be there as I teach them, and you'll be able to find them easily, but it's your option. You can have AutoCAD open whatever way you like. So, okay. So step one is to trace over those pieces. I guess you could say that that line there is not needed, but I'll keep it in there in the meantime. Step two also is to import these figures, these beams and columns and angles from the drawing that I've left on Moodle. And step three is now to bring in our 3D commands. So to do this, if you've got AutoCAD open, you can follow through and do this now. Come to a blank area. Now there's a blank area at the bottom of this one. There's a blank area over here as well. I'm gonna right click here. So right click and click on AutoCAD. And you need to turn modeling on. Modeling on, that one. So you can see here that I've got, now some of you like to put that on the other screen. Because I'm demonstrating, I'll put mine just up here in the corner so that it's away from things. But if you hold your hand on different things, you'll see that the options are there to draw things like cones, boxes, spheres, and solids as well. The ones that I'm going to be showing you, you're welcome to experiment with those. There's a lot of fun involved in that, but really the ones that you need for this the extrude command here, this one here, extrude. This one here, which is called union, where you join two solids together. And you might like to look at subtract if you're going to put any holes or anything in there for nuts or bolts. Lastly, I'm going to be using 3D rotate. So, have I got a layer here called a button? Yep, I have. So I'm going to change that and that onto a layer called the button, which is white. The next step I'm going to do is I'm going to look at it in different views. Now you're welcome to do all sorts of views if you want. Just a quick recap on how 3D works. You can hold down your shift key and your middle roller, your control key in the middle roller, make that the shift key in the middle roller, and you can turn things around in 3D. Okay, or you can go view, 3D views, and you can look from the top, or you can go view, 3D views, look from the bottom, or the right, or the front. In this case, the one I like to work with is what's called the southwest isometric. And it gives you an idea of what you're building up in 3D, in a 3D view. Notice that everything's flat at the moment. So if I actually went and looked at it from the front on, it would be view, 3D views, front, and it's just a single line because we don't have anything in 3D at the moment, right? But I won't. I'll go view, the way I like to do it, 3D views, and southwest isometric. Now I'm just zooming in there, using my zoom key. Okay. Now, it's probably easier to demonstrate if I have the model rendered a little bit. So I'm going to go back up here to view, and I'm going to go view, visual styles, and realistic. Now you don't really know what I've done there, but you'll see what I've done in a minute. Actually, let's just go back to our normal view, 3D views, view, visual styles, 2D wireframe. Okay. Extrude, which is this one here. Click on the extrude, click on the middle piece, maybe the other middle piece as well. Go enter. Aim upwards with ortho on and type in a number. Does anyone know what number I should be typing in? How much up does that stick? I would suggest it sticks 525, is that right? Yep. 525, enter. Okay. And I'm going to click on these bottom twos, enter, and click on extrude again, aim downwards, and how much down is that? 350? Yeah. 350, hope it is. I'll just check that. See the beauty of having this all drawn up. No, it doesn't actually have the 350 on it. Okay, doesn't matter. That's 350. So that's the 2D wireframe. If I was to go back to view, visual styles, and realistic, all of a sudden, I don't know what it's looking like, you can see things are starting to look quite a bit more 3D-ish and a bit more realistic, right? Now, these are two separate entities, and I'll be checking this on your drawing, so I want you to actually join those. Now, it's not that difficult to do. There's a command up here on your modelling tools called union, and it says here, if you always read everything first, it's easy to do it. You can combine two or more 3D solid surfaces or 2D regions into a single composite 3D solid surface or region. You must select the same type of objects to combine. So let's grab it, click on that one, and go enter. Okay, you'll now see the whole thing as one big combined abutment. Do it on the other one, click on union, click on that one, and go enter. So there we are. It's one complete solid now joined together. Well, so far, so good. The top of this abutment piece here is the level we seem to be using at the moment. Now, I would like to draw in here what I call a packer. So I'm going to make a layer called packer. I'll do it the proper way, sorry. Make a layer up, call it packer, and I'll make it go. Oh, packer's already there. How about that? There it is. Now I'm going to go P-line from that point to that point to that point. No, one in. Oh, sorry. We're going to aim up. The packer is 85, by the way. Let's try and do that packer again. Oh, by the way, it's gone hidden. So I'll go back and make that continuous. So I'm going to do a P-line from here to here. I'm going to go up 85, back over here. How long is that one? 700, is it? No. 450, is it? And closed. Now I'm going to extrude that. 3/400. And I'm going to copy that to the other side. So I'll put my packer on both sides. Now for the beam. Which one's the beam? The beams, remember I said in class the beam was always the fatter one in the X direction. So this is our beam. The beam is always the skinnier one. This is our beam here. Can anyone tell me how long the beam's going to be? Okay, well let's have a look over here. By memory, it is 15 mil short. So it's 13,000 minus 30 mil. So I'm going to extrude that. This is really important, this bit. We'll click on here, enter, and we're going to extrude it up in the air by 12970. That should be on the layer called beam. Now the beam's kind of not really facing the right way. We need to turn it around. So we go to the rotate command over here. Where is that? Oh, sorry. Delete it instead. Rotate. Click on here. Enter. We're having some trouble finding our beam. There it is. I think I've rotated it. No, I haven't. rotate. Yeah, I'll just undo a couple of commands there. Any ideas, Tom? No, 3D rotates. Oh, I could do 3D rotate, but that's only going to put it the other way around. So what I need to do probably is rotate it first before I extrude it. So just going back on this one. Sorry, guys. So what I'm going to do is rotate this beam first. I'm rotating this beam before I actually so I go to plan view, view, 3D views, top. So I'm going to rotate this beam in this direction. Now I'm going to go back to view, 3D views, southwest isometric. I'm going to click on here and I'm going to type extrude, go to the extrude, 12970, enter, change that to the layer called beam. So now I want to flip this beam down, and to do that we go to 3D rotate, we click on here, enter, and we click on the green one. You see the green one there? Click on the green circle, aim upwards, and click again, and we've rotated the beam in the position that we need to put it. So I'll just go over that again. I rotated this beam first all in plan view, and then I went to 3D rotate. I clicked on here, enter, and I clicked on the green circle and it turned orange. And then I aimed upwards and clicked upwards, and it left the beam in the position that I wanted it to be. Now I'm going to move the beam from this corner point down into that location there. I'll show you why in a minute. In a minute I'm going to move the beam into its correct location. Next up is the columns. First column, I'm going to extrude that by 6 meters. The next column, I'm going to extrude that by 8 meters. Hopefully you guys had these dimensions, or close to it. And I'm going to copy that 6 meter column, and I'm going to put it over here on top of that. I'm calling them columns, they're actually posts. Alright, so in plan view, this should sit hard up against these posts. So we need to go to plan view, which is view, 3D views, top. And we need to come in and we need to move this beam from nearest point here, perpendicular to here. And in plan view, I'm also going to mirror. I'm sorry, we need to move the beam along 15 mils in that direction. So we've got a 15 mil gap there and 15 mil gap there. So I just moved it in plan view. Now I'm going to do something a little bit more cleverer. I'm going to mirror that beam to save me doing it all again. Enter, from the midpoint here name over here somewhere, and go click, and N for no. Don't want to delete the old one. Now I'm going to mirror again everything with the green window, everything, all of those plus that. Enter from the midpoint of here across to the other side, and do I want to delete the old one? N, enter. So, how's it all going? Does it look like it's working? Let's have a look. View, 3D views, southwest isometric. Looking pretty good, but the posts are going to have to come up. The posts at the moment are sitting at that level down here, and they need to come up by 525. Let's try, and also these beams need to come up as well. The beams need to come up by the packing, and the posts need to. Let's move everything up by the packing, which is 85. So I'm now moving everything up by 85.
I think you didn't select those two.
Didn't select what?
These two before.
Oh, you're right. You're right. Yeah, well done. I didn't select those two.
Yeah.
Yeah, you're right. 85. Yeah, so they're up too. I don't think I selected these, did I?
I don't know.
I'm not sure either.
I think you did those twice.
We'll get back to that. The column. Column is 3110, so I'm going to extrude the column. Three 110.
That wasn't.
That was a lot more than 3110. Click on here. Extrude. I have not been drinking. 3110. Well, that's my excuse. Okay, so it's green now, we can notice it. So we need to do a 3D rotate on this one as well. Just to click on it, enter, and click on the red line this time, make it turn orange, and aim upwards, and we've rotated it in the right position. You get used to the 3D rotate, it's a wee bit of a mission first up. But anyway, I'm going to move the column to that point down here, which is my circle, and then I'm going to move it up by 285, which is your packer plus the piece underneath. And you're right, I think we moved this one here twice. So we now need to position the columns all the way along. This last one will fit, if I want to turn it around a little bit, the last one will go right to that point there. I had my circle here somewhere. Seem to have lost it. Never mind. Anyway, that will be 15 mils off there. So I'll do a line from here to here. I'll move that line mils. So I've now got a line to move to copy this to. I'm going to copy that from the end point of here, perpendicular to that white line. And now I can copy these columns from my circle to my next circle, to my next circle, and so on. And I'll mirror that that's why it's good to keep this line here, because we can use that as our mirror line. So if I want to mirror that green one on the other side, we can do it from the midpoint of this line here somewhere. There it is. Across. And voila, we've mirrored down to here. The next thing I'm going to do is put boards on there, but before I do that, I'd like to try and get these posts at the right height. They're currently, they look to be 85 mils short of the top of that beam. So I'm going to have a go at trying to move them all 85 mils up. Every time I do this, it seems to go wrong, but I'll try. Aim up and type in 85 mils. They look like they're pretty damn close. Yep, we've done it. So now we need to have a quick look at our drawing to see how high this is still going to go. So looking over here, at the moment, it's sitting right underneath there, so I've got 200 plus, I've got the decking board of 40, oh no, I've got 1150 plus 200. So 1350 is what I've got to move it up. See how useful it is still having your drawing drawn up? You can still do it mathematically. So I'm going to move all this up by 1350.
No.
Yes?
Put a 1 in the front.
No.
Put a 1.
Yes. 1350. Okay, so those posts are now at the perfect height, ready for our angle over here. What we haven't done is our decking boards on top. So to do a decking board, I'm going to draw the decking board over here first. So I'm going to do a P line from here, 13, 1, 2, 3, enter. Decking boards are 140 wide, enter. Back up here 1300, and then back to here. Of course, we have to extrude the decking board. They're 40 high. So there's our 140 by 40 decking board. Let's move it into location, which would be at the end of here. But we've still got, I think, 15 mils to go. Anyway, something's not quite right with my drawing in terms of the heights of the decking board, but I think my pack is a little bit too big. But anyway, all we have to do is copy that decking board from point to point to point, and that actually gives us the bridge across. I've got a feeling I didn't quite draw the abutment at the right height, because that definitely is 85 according to my calculations. So anyway, my abutment's drawn slightly wrong. But anyway, you're getting a good demonstration from 3D. Let's let's make our angle colour yellow. And our angle is going to be 1150 minus 40. So 1110. Oh, and also minus 10 for the plate and minus 10 for the plate at the other end. What does that make? 1090. Hopefully you'll got that length of the angle on your calculations. I'm going to say this because I know exactly what's going to happen right at the critical time. So I'm going to extrude this 1090. Change that to the layer called angle. And I'm going to make a layer called plate. And I'm going to do a plate on top, which will be 75 that way, 75 that way, and close it. I'm going to extrude that up 10 mil. I think my my angle's slightly wrong to the one that's it is. The one that you guys have got here. I'll bring it in. So I'm going to move that angle from that point over to here. I'm going to copy that down to the bottom. We've now got our plate with our angle on it. For some reason it's not copying, it's doing a bit of a pain. That's better. Okay, so we need to move this into the correct location on here. Like what?
Does it like hang off the angle like that? You just put it on the corner?
You normally would put it on the corner, but you probably have to leave 10 mils for welding. So, we
Well,
would,
like for those two, you just do it in the corner?
you can do it, you probably can just leave it on the corner, but you can do, where it would sit would probably be 10 mils in both directions, so that you can get a weld around here. Okay? So, I guess that's a little bit more cleverer than what I did, so that's fine. So you put one there, you'll mirror that to the other side. From the midpoint of here to the other side. And then you'll mirror that. Looks a bit strange with it sticking up in the air, but you would put the smooth side facing where the people are going to be walking. And you mirror that from the midpoint across there. And then what's left to do is to put the timber on top.
Where are you going to put that angle in place? What is
It would be See how these boards are sticking out? That's not correct. This abutment will be a little bit bigger.
But do you have it like at the edge of the boards? You just put it in there.
It doesn't matter because it bolts down through the boards. Can go anywhere on the boards. It's probably preferable to be at the very end, I guess. Yep. Couple of that was it is
Yeah, but like, if you have like 3 boards in on one side and then on the other side on the edge of the boards. So like, is there no distance that it needs to be in?
yeah, it's all let me see. I would put it in as close to the end as you can and centered on this board here. So if you're doing it here, you do it from the midpoint of here, right? Let's look at the plan view. View, 3D views top. Okay, so it needs to be in line with this, and it needs to be
On the edge.
on the edge. So in here. Right? Hold on. I'm only doing this to give you guys an idea of 3D. So we'll sit there. So I could, I guess, copy that over to the other drawing and place it exactly into position. But I'm not going to because I'm being lazy. With the board, the last board that we're going to draw was put on a layer called we don't have a layer to use. Decking, I suppose. Put on the decking layer. This will be on a layer called handrail. P line from here 3 meters. Sorry, 13 meters. It is 75 by 100, so the 100 will be on the flat. And then back to the extrude that 75, and basically that would end up being there. But of course, sticking out a bit at the other end because we haven't lined it. That one, sorry, that would go from there to that point, and then that would give you an idea of where to move this to, which we should have actually gone to, but it didn't. So do you see there's where that should be, okay? And I think now that I've got it correctly, I'll mirror the whole thing to the other side. The mirror command, guys, is something that you'll use a lot. Once you get one of these angles and boards in place, you can then mirror both ends to the other side. Just trying to, there it is. Found it. So that's your basic bridge drawn. Obviously, you've still got to put in your whalers and your angled members as well, which is it's tricky, and I'm not going to show you how to do everything. You are going to have to try and make that up yourself to do that. Some tips. It's a very good idea to draw these things up. Say, for example, 3D views from the front. So there we have it there. You draw your cross members on, then you go back to the other view, and you go to views, 3D views, this view here, and then move them onto each particular timber member. So we have this lab for you to have a bit of a go and try and start some of this off. Then you've got an opportunity maybe after the test next week to show me how your 3D is going and ask any further questions. When you get into this, you'll actually find it a lot more fun. Oh, what I haven't done is shown you what I would do with my 3D drawing. So here's the viewport. It doesn't have to be to scale, not to scale, but I want to see a maximum view. I don't want to see somebody showing me a 3D view like this, and I don't even want them to go view 3D views southwest, and you know that's not good enough in the viewport. It needs to maximise the viewport as best as possible, and I also want it to be visual styles, either realistic or conceptual. I prefer realistic. So that's kind of where I want you to leave that drawing for me. Now, also, that's probably the best view. I don't really want you to leave it in a view like, for example, holding my shift key down, let's go inside the viewport. You know, that view's no good, or even that view either, because you can't see what's going on. So you need to have some sort of view that allows you to see what's going on. And of course, you can have a look at my own 3D view that I've done on Moodle, and you'll see the sort of view that I'm looking for. So just to recap, 3 marks for that. If you want to go further and you want to put on the likes of, let me see, a circle, say that's your split ring, and you might give it, say, 20 mils. So you might want to extrude that by 20 mils. And then you can 3D flip that. And then you might want to paste that on the side of, let's change its colour so we can see it. You might want to put that there and call it a split ring, for example, on the side of your post. Or you can do the same thing with, for example, a bolt. Here's a 16 mil bolt, for example. You can draw that up by using a circle in 2D and draw a hexagon shape, extrude the hexagon shape, and then on the other side of the bolt you can have a cylinder there, and you can use a basic command to do a cylinder. So for a cylinder, for example, if you wanted to do a hole, I'll show you how you do a hole. Let's do a cylinder, so we do a circle. We extrude the circle. We move the circle onto and through an object. So I'll change its colour so you can see it, because everything seems to be white at the moment. I'm going to move that so that it's okay. Can you all see how that's gone into the column? So it's sticking through the column, right? So we can come up here and use a command called subtract. So select the objects you want to keep and then press enter, then select the objects you want to subtract. So I'm going to click on here, I'm going to click on my post, I want to keep that, enter, and then I can click on this, and enter, and it puts a perfectly formed hole in the post. Look at that. So they're all things you can do to improve your mark. There was one student said to me, well, how do I do a 3D of the ground? Okay, well say for example your ground went like this. I'm just doing contours here, by the way. Okay, so if you want to form a face, you go 3D face, and you start drawing on top of your face, and it starts forming 3D faces. So type 3D face. I'm just doing a whole lot of faces here at the moment in triangles. You know how your ground contours were in survey triangles? Now if you type 3D face, and you click on each corner of the triangle, enter again for the same command, you can start forming the ground line. And that's a really cool command for working your way around contours and forming the ground lines around objects. 3D face. Alright? To do that, of course, so you can do it between contours, but you've got to move your contours into the correct height. Because at the moment all your contours on your drawing are at height 0. So you have to move them up and down by me, like I was moving the posts up and down. Alright, well that's the challenge in 3D. The rest of it is basically drawing up the elevations and the sections and a couple of details. And that's your final assignment. Any questions? Best things to roll your sleeves up and have a go at it. Stop talking now.